Today, I'm going to do unspeakable things to a donut spare. This sad little wheel was designed to get you home at 45 miles per hour. I have other plans. We're going to cut this thing up and we're going to turn it into a 20 by 10 wheel for a mini truck. Is this a good idea? I don't know, but I'm going to do it anyway. So, all you criers in the comments about doing unsafe things, I don't care. It's going to look cool. I'm going to do it anyway. Hang out. Alright, so the first thing I'm going to do is get this mounted up in my mill. It's an old Bridgeport Series 1. This is my rotary table. This is a soft table. And this is the wheel that I'm going to mount on here. Now, in order to do this, technically you don't have to be super centered, but I like to make sure I am on the rough cuts. So I'm going to end up centering the rotary table, I'm going to center the soft table, and then I'm going to center the wheel. At that point, I can move in an X direction or a Y direction and get back to dead center every time. So let me get that mounted up, and then we'll start cutting. That's an R8 collet to an MT2 taper. It's a live center. This isn't a perfect way to do it, but for what I'm doing, it'll get you as close as you'd ever need to be. Oops. I prefer this and try and use it when I can. Which is why I'm using a soft table instead of just putting a bigger rotary table down in my mill. It's too freaking heavy. So not scrap. And back on this guy. Got a much cleaner shot now. I'm going to take this off. Essentially just pull the rest of the barrel off. It'll end up being a 20, so I'll time lapse the next cut, and then this guy goes on the lathe for some finishing. Scrap. Next. Test fit this thing, see how we're doing. Oh, amazing. God damn. Looking forward to the refinish on these. These will be pretty wild. Thought about keeping the 45 mph sticker on there because it's kind of fun, but the yellow is a bit too much for me. All right, now that we're done with the lathe work, I think we'll pop this back on the mill. Probably do some final cleanup with the end mill, and then I'll work into drilling out the bolt pattern. Yeah, getting the counter boring done, and then do a quick last test fit, and then this goes in the stripper tank. We'll see what we come up with for some finishes. Fun times. My last couple of videos, you guys asked for more information, maybe to be educated a little bit, show you how I do some of the things that I do. This is not going to be an educational channel, but I do see value in showing some of this stuff. I'm about to drill the holes in the face, and I wanted to go over a few terms and explain a basic level how I do what I do. So this build is going to be made with 20-inch step parts, which would be the same as a 19-inch reverse. It's US 40-hole pattern is what I'm using. So a few definitions here. We'll do P, C, D. This is pitch, circle, diameter. We'll do inner bore, and we'll define US 40 hole pattern. Now this is for, like I said, 20-inch step parts or 19-inch reverse. 20-inch step, 19-inch reverse. Good luck reading any of this, but I will narrate it, so you won't be able to read my writing. You can at least hear my mouth. All right, PCD is, I think, the easiest way to kind of define all of this. Just draw a picture. We'll trace it. And this portion is going to be the step. This is your bolt flange. PCD is the diameter from the center of the bolt circle to the center of the bolt circle. This dimension right here on a 20-inch step or 19-inch reverse is 17 and a half inches, yeah. That is the same for all US 40 hole pattern 19-inch reverse lips. The inner bore diameter is going to be from here to here. This is 16.91 inches. That is a standard measurement on all 19-inch reverse or 20-inch step parts. These two numbers are the same on all of them. In this case, the 40 hole pattern, I know there's going to be 40 bolts. There are 360 degrees in a circle. 360 divided by 40 is 9 degrees. I just know that because I do this all the time. So when I go to drill these holes, I'm going to be using my rotary table. Every 9 degrees, drill a hole. 9 degrees, drill a hole. And that will give me 40 total holes around the circumference. And what I'll do is I zeroed out my rotary table in the center of the wheel. So I know that if this is 17.5 and I'm centered right here, if I move my X axis on my mill, 17.5 divided by 2, which is what? 8.75. Now I know that when I set up on my rotary table, if I move my X 8.75 inches from center, I can then drill my 40 bolt pattern. I can drill a hole every 9 degrees. And I'll end up with the perfect pattern for the 20-inch step parts. Right. I'll be drilling these holes with an M8 end mill. It's a 6 flute. It's designed for hole drilling. I don't like using standard drill bits. They tend to walk, even on a mill, even with the most solid surface. The drill bit tends to walk, so I choose to buy an end mill that's designed for drilling, and it works way better. So I'll get you turned around, get these holes drilled, and then one last test fit, and then it's time to refinish these things, which is what I'm really looking forward to. So, all right, so I got this mounted and centered on my rotary table, zeroed out, dead center. Plan would be to shuffle this in the negative direction on the X. We're going to move 8.75 or 222 millimeters. Now let's see. Got a test hole lined up, dead on. So now I'm going to drill the PCD out every 9 degrees. I'm going to drill a new hole. What I'm going to do down here is zero it out at 20. So instead of 0, 9, 18, we're going to do 20, 29, 38, 47. So we'll just go 9 degrees from 20. We'll get that centered here. There we go. Then we'll get to drilling. All right, I got the face stripped. Turned out pretty decent. It's a nice factory machine finish. It's almost savable, but got some water damage through the, you can see a little bit right here, through the epoxy paint that they had put on this. So just spin that out and have it match is not really gonna work. If I had a diamond cutting machine, I could do it, but I don't. So I might end up brushing these faces all the way out. Before I do that though, there's some welding that I've got to do. I'm going to close up this valve stem hole that's no longer needed. I may or may not add thickness to this. We're at 6 mils, which is pretty good. The truck is very light. I'm not putting this on a 5,000 pound vehicle. It's my own personal one actually. So we'll see. It adds a lot of time to weld in that extra thickness on the flange. It's usually worth it. On a wheel like this, for my own self, I've run these before. It'll be fine. You can cry about it if you want. It will be fine. If it was a customer's car, I probably would weld the band on there, keep the thickness up, probably get it to 10 or 12 mils before I quit. But at 6.5 mils, this isn't going anywhere. But I'll get this thing tossed in the oven. I'm going to preheat it to about 200, 250. Take it out and do some welding. So we'll catch back up in a few. That sucked. Normally I don't. Oh my god, look at me. Normally I don't mask. I've got a powder vacuum that does a really good job at removing powder where you don't want it. I'm doing something real weird on these though. So the two-tone, it needs to be masked because I've got a step between this and the clear on the laser engraver. So the only way I can do that neatly is with high temp tape masking this off. So let me get this thing coated, get in the oven, and then move on to the next step. Oh, I'm fucking dirty. So, faces are looking awesome. Fully brushed, cleared. I got my logo engraved in the face of the wheel. It's pretty neat. I think the entire goal was to try and make it look like a 6-spoke wheel rather than a donut with a weird block in between spokes. It's kind of a strange thing, but I think it came out pretty good. Custom center caps, they're just flat caps, brushed out, cleared. And now I'm gonna move into assembly and we'll get some final picks. Wow. Frickin' wild. Goddamn 17x4 donut. Love it. I'm reminded of a saying that we all heard growing up. Just because you can do it doesn't mean you should. I call bullshit. If you can do it, you should do it. I wasn't sure if this could happen, but it did, and it's done. It's one of those things, you never know where your limits are or what the limits are on materials until you just do it. I mean, I can truly say this is the only set of these that exists. Was it a good idea? I think so. I can't wait to get them on my car. And I know a lot of you have been asking for final shots of the wheels on vehicles. I'm trying, that's a lot harder to coordinate. Whereas this one is a bit easier because it's my vehicle, but I'm so backed up with wheels that I haven't had time to work on my own shit in so long. So this is what I do. I try and use a little bit of time to build something that I think maybe you guys would want to see or something that's never been done before. And this is the motivation for me to finish my project. So many of my customers are the same way. Vehicles 90% done on jack stands, lost motivation over 2 or 3 year build. And the wheels, when they're done and they get their hands on them, is the motivation to just finish the project. So that's what this is for me. I think they came out amazing. Super odd with this weird window that's filled in. The laser engraving didn't come out that great. I ended up having to do multiple layers of powder and then try and remove the powder, which took higher laser power. And by the time I was done ramping up the laser power, you couldn't really tell the difference from the background to the engraving, but it is subtle, and I think it does accomplish what I wanted. So thanks for hanging out. I don't know what's coming up next. I always tell you guys what's coming up next, and then I get it wrong. So we'll see what happens. Yeah, thanks for hanging out. Thanks for showing up. Fake wheels burn in hell.